In this video, I'm going to demonstrate the Web3.js plugin for ZK Sync. And in particular, I'm going to be using the ZK Sync CLI to create two different types of projects. A scripting project that uses Node.js for backend or server-side development, and then a Next.js project that uses ZK Sync on the front end for client-side development. So without any further ado, let's get right into things. I'm here on the GitHub README for the ZK Sync CLI. You can see there's all sorts of usage documentation here, but what I'm interested in today is using it to create a project. And that's pretty simple. We just use the npx ZK-Sync CLI create command. So let's open up a terminal and get started. npx ZK-Sync CLI create. And we're going to get started with the Node.js scripting project. So I'm going to call this Web3 ZK Sync Node. And it's going to be scripting. We're going to use Web3.js and just use npm for our package manager. And so what this is doing now is pulling down the template and installing the dependencies with npm. So let's take a look at what we've gotten in Visual Studio Code. Close this one. Okay, so here's our project. And let's open up the README. We'll render it so it looks pretty. So it says this is a ZK Sync plus Web3.js plus Node project. It's written in TypeScript, and it was bootstrapped with the ZK Sync CLI. We have some getting started instructions here. First, we have to run npm install, which we can see the ZK Sync CLI took care of for us because we have our Node modules there. We write our code in src main, and then we use npm start to see what we got. But before we dig into the code, let's take a look at some documentation, and let's actually get started with the SDK docs for the plugin. This has a complete overview of all the different capabilities that's exposed by the plugin. Today for this video, just to keep things kind of simple, we're going to focus on the RPC methods, but you can see that the plugin itself implements a wallet. We can add custom transaction data, interact with paymasters, interact with ZK Sync smart contracts, use ZK Sync smart accounts, which is the ZK Sync account abstraction implementation. So it's a very fully featured ZK Sync SDK. Also, in addition to the SDK docs, which is kind of like explanation and usage, we have the API documentation, which kind of goes over a lot of what we just talked about. And then it has comprehensive API documentation. So for instance, here's the plugin itself. We can see that it has all these different properties and accessors. Like there's an RPC accessor, which exposes this RPC methods class. That's documented here. So we're going to be looking at all of this a little bit more closely, but just kind of wanted to give you a start. And so you can see where you can go to look for more details if you start hacking on this stuff and you need some documentation. So let's go back to our project and let's open up src main and see what we can see. It's a bunch of comments here. Some more, a lot of what we saw on the README, but we can see that one thing that we're doing is pulling in some of these examples, which are written here. So we have examples of working with contracts, examples of working with the wallet, but what we're going to look at today, as I mentioned, is the RPC interaction. So we can open up this RPC example and see that what we're doing is pulling in our dependencies, Web3.js and the ZK Sync plugin, and then a few helper classes and types. We create a new Web3.js instance, which we're omitting the provider parameter because we're not doing any interaction with layer 1 in this. It's all with layer 2. So we don't need to have a layer 1 provider. And then we register a plugin and we create a new ZK Sync plugin instance and use this helper function, init with default provider, to connect to the ZK Sync Sepolia test network. Then once we have our ZK Sync instance available on the Web3 object that we created, just pull that out to make it a little bit friendlier to work with. And then we can use the RPC to get the testnet paymaster address and print that to the console. So let's run this and just see it in action. Uncomment that, and then we'll do npm start. So there is our testnet paymaster address. And now, just to kind of reinforce what we just talked about, let's do it ourselves from scratch. So we're going to import Web3. And then we're going to import what we saw from the plugin, Web3 plugin ZK Sync. We have some types. We have our layer 2 provider, and we have the plugin itself. And then just like we saw, we create an instance of Web3, not worrying about passing in a provider because we're not going to be interacting with layer 1 in this example. And then we say web3.register plugin, and we say new ZK Sync plugin, and we're going to use that layer 2 helper method, init with default provider. And from our types package, we're going to pull in the network's enum and use the Sepolia network. And then just to make things kind of prettier, we'll say const ZKsync equals web3.ZKsync. And since we're doing this in TypeScript, let's go ahead and add our types. And we'll call this ZK Sync plugin. And so we saw how to get the testnet paymaster address. This time we're going to print out the main contract address. And so I don't have to mess around with async await. I'm just going to do it like a normal native JavaScript function promise. So we're going to say ZKsync.rpc.getMainContract. And then that's going to resolve to a string. So we'll just log that to the console. So let's take a look at this. Yes, I already commented that out. So let's run this. There is our main contract address. So pretty quick introduction to the scripting template. Just gives you an idea of how to register the plugin with Web3.js and use it to interact with the ZK Sync network. So now we're going to move on to the front end. So I'm all done with this project. I'm going to close that. And I'm going to just delete that, just clean it up. And now we're going to create our front end project. So npx ZK Sync CLI create. And we're going to call this Web3 ZK Sync Frontend. It's a front end project. We're going to use Next. There's also a Vite, I believe that's the way. It's the React one, Vite or Vite. I'm not much of a front end developer, but there's a Web3.js template in Vite. But we're going to use the Next.js one, probably because I find it easier to say. We're still going to use npm. Takes a little bit longer to install these dependencies because it's bringing in that whole front end framework. So just give it a second here. All right, and now we're going to open it up in VS Code just like before. Okay, so here's our project, and we're going to get started at the README again, just like before. So ZK Sync, Web3.js, Next, bootstrapped with the ZK Sync CLI. And it says to get started, we just run npm run dev, and then we'll have the template running locally on port 3000. So let's get started there. Okay, running on localhost 3000. So let's take a look at that. Here is the front end template. It is going to list the account that we're using, which let's take a look at one thing. This is using the MetaMask account. You can see it says we're connected to Sepolia. MetaMask here is connected to Sepolia, and it's this 930 account, just like we see here, and the balances match up. We got our block number. We can do some other fun stuff like sign a message. Hello, ZK Sync. Get our nice friendly MetaMask pop-up. We see the signature of the message and the address that was used to sign it. We can get information about a token. And then there's all sorts of other stuff that we can do. But let's go back to the project itself and look around a little bit. If you are a front-end developer, you're probably pretty familiar with the idea of a context. So all of those different components that we were looking at, the account component, the balance component, the block number component, the sign a message component, they're all sharing this context, which has the ZK Sync plugin available to it. And that's how they're getting access to the ZK Sync network. So here is our context. And what we're going to see is that this context exposes this Ethereum context. Sorry, scrolling around a little bit, but just want to get to the definition of that interface. So this Ethereum context exposes all sorts of things like the account, the network that we're connected to, and the ZK Sync plugin. So this should all look pretty familiar to you. What we're doing is creating a new instance of the ZK Sync plugin, but this time we are using the MetaMask injected Ethereum provider, getting it off of our global window object. And we're actually going to see in a second that that creates some limitations, but then we're going to make some changes to this project and get around those limitations. So I think that pretty much demonstrates what I wanted to show off for the context, just that it provides a way for the rest of the components in the project to access the ZK Sync context. So let's take a look at the block number component and kind of see this in action. We have that use Ethereum method that the context exposes that provides that ZK Sync get ZK Sync method. We're pulling that in right here. Close that. And then we're using that ZK Sync plugin to get some more information. And yeah, now what if we wanted to access the ZK Sync RPC like we did before? Let's try to get that main contract address like we did. So I'm going to add some more state to this project for the ZK Sync main contract address, which is a string, or maybe it's null. It starts out as null. And we're just going to call that main contract address and set main contract address. And then here, I'm just going to use the existing block number component rather than creating a brand new component, just because it would be a lot more boilerplate and everything. In production or in your hackathon, you'd probably want to create your own brand new component, but just to kind of demonstrate how things work here, I'm just going to reuse some of the existing boilerplate. So let's say we're going to set our main contract address. And we're going to say await. We can use async await now. And we're going to do ZKsync.RPC.getMainContract, just like we did before. And let's see what happens. There is a problem. It says the method ZKsGetMainContract does not exist. And that's because we are using the injected MetaMask and Ethereum provider to access the ZK Sync network. And MetaMask does not implement these ZK Sync specific RPC methods. So what we're going to do now is update the context for the front end template to expose an RPC provider that's not connected through MetaMask. It's connected through a normal node provider, and use that to access the ZK Sync specific RPCs. So let's take a look at how we would do that. We're going to go to the documentation, to RPC methods, and here it says that the JSON-RPC is implemented by the RPC methods class, which is exposed by the ZK Sync plugin RPC property, like we saw. And here is the documentation for the RPC methods class on our API documentation. And if we want to construct a new one, we need to pass in this Web3 request manager thing, which is a native Web3 object. So we're going to go to the Web3.js docs and see if we can learn a little bit more about Web3 request manager. The first thing that we're going to notice is that it's part of the Web3 core package. And then we're going to take a look at the constructor and see that we need to provide a string, which is the URL of the RPC provider. So let's start hacking on this. The first thing that we're going to need to do is pull in that Web3 core package so that we have access to the Web3 request manager. So I'm going to say npm I web3 core, install that dependency, and then we're going to import the Web3 request manager. Okay. And next we are going to, just like we have a plugin here, placeholder for the plugin here, we're going to create a placeholder for the RPC. Oops, we need to pull that in. RPC methods from the plugin, because we're going to create that all by itself. So this is going to be RPC methods or null. And to start out, it's going to be null. This is where we are creating the ZK Sync plugin. And so we're going to create our RPC equals new RPC methods. And what we saw is that we need to pass in the Web3 request manager. And now we need to get the URL for the provider that we want to use. So let's say ZKsync Sepolia RPC URL. And this is documented on the ZKsync docs. Right here, we have the Sepolia testnet network details, and we're just going to grab the RPC URL. So there we go. So this is where we expose that get ZKsync method. We're going to create a similar one, get ZK-RPC. That's going to our ZK-RPC. And then we're going to add that to the context, and we need to update the context definition because that's not part of the interface right now. So we'll go back up here and just say get ZK RPC. It's going to be a method that returns either an RPC methods class or null. And so now that error has cleared. So now we're going to have access to that layer 2 ZK Sync RPC request manager from our context. So let's go back to the block number component, and we will bring in get ZK RPC from the context. And since that may be null, we're going to have to change this a little bit. Well, first, let's get the RPC. Okay. And then we'll say if that's not null, just make sure that it's been instantiated. And then we're going to update this. And update that a little bit. So now rather than using the ZK Sync plugin, which is using the MetaMask provider, which doesn't implement the ZK Sync specific RPCs, we're going to use that special RPC methods class that we connected to a regular ZK Sync Sepolia node that does implement those RPC methods. And then we use the return value of that to set our state on the component. And so let's see if we can get this printed out. We'll add a break there. And then we'll say main contract address. So let's see how things look. The error's gone away. And right underneath the block number, we have our main contract address. So we did it. We can now call ZK Sync specific RPC methods from the front end template. So that's pretty much the demo. I hope it wasn't too long, but I wanted to make sure that I gave you a good idea of how to use the ZK Sync plugin, how to use the ZK Sync CLI. So we went over using the ZK Sync CLI to create a Node.js backend project, saw how to create a new instance of the ZK Sync plugin, register it with Web3, use it to interact with the RPC. And then we also looked at the front end template a little bit using Next.js to create a ZK Sync powered dApp and getting around this sort of limitation where the injected MetaMask, or really the browser injected Ethereum provider, typically is not going to implement the ZK Sync specific RPCs. So if you want to build a dApp that makes use of some of those ZK Sync specific RPCs, you now know how to update the template to do so. So I really hope this was helpful. I hope it got you excited about hacking with ZK Sync. If you have any questions, if you have any problems, please head over to the GitHub page for the ZK Sync plugin for Web3.js, open an issue, and me or someone else from ChainSafe will be more than happy to help you out and get you going. So thank you very much for your time, and happy hacking.